All right, let's get started. Welcome, everyone, and thank you for joining another DevTest Community Webcast. Today our topic is SAP and Service Virtualization, and our presenter today is Ulrich Vogt. He is the Senior Principal Engineering Services Architect for the SV product. If you have any questions as we're going through our session today, please feel free to enter them into the Q&A box in the bottom right-hand corner of your screen, and we'll get to all of the questions at the end of today's session. At the end of the session, we'll also be opening the line up for verbal questions. So if you have any questions you'd like to ask over the phone, you can hold your questions until the end. I'm now going to hand the call over to Ulrich. Go ahead, Ulrich.
Hello, this is Ulrich from the Continuous Delivery BU Engineering Services team. Can you see my desktop?
Yep, it looks good.
Yep, okay, thanks. Well, today's webcast is we'll go over the capability in DevTest to virtualize SAP services. DevTest supports the virtualization of SAP services based on the exchange of IDocs. For the SAP service virtualization in DevTest, we will use the DevTest components portal and workstation to create, launch, and monitor virtual SAP services and the VSE to run them. We will first talk about some basics of the SAP architecture as far as it concerns connectivity to and from external SAP service providers, such as DevTest. We will then cover the communication between DevTest and SAP and the configuration of DevTest in order to communicate to an SAP system and an SAP service. In our demo, we will record an SAP service, create a virtual service from the recording, and run it. If time permits, we will rush through some useful commands in the SAP UI. In SAP, these commands are called transaction codes, and these transaction codes may help to analyze, validate, review, or even modify SAP configuration settings and run applications. At the end, we will hopefully have some time left for questions and answers. At CA World, I was asked if DevTest can virtualize an entire SAP system. Well, that's not the case. DevTest virtualizes SAP services, and particularly only those SAP services that are based on IDocs. IDoc-based services are central to SAP. In order to virtualize those SAP services, we always need a real SAP system to connect to. The architecture of an SAP system is very complex, and even the basic introduction into this architecture will take hours to explain. So we cover only those topics that we need to understand and to know to set up DevTest to be able to talk to an SAP system. In general, SAP is organized as a regular three-tier architecture. It comprises of a presentation layer implemented in front-end systems such as the SAP GUI application. The application layer does the business logic and retrieves data from and stores data in the third layer, the database layer. With DevTest, we virtualize SAP services in the application layer. Looking at an SAP system from an external program, we have two options to connect to the system actively. First, we can connect to a specific SAP instance, which is part of a bigger SAP system. An SAP instance comprises of a dispatcher, at least two dialog processes, a memory, and a gateway process, and the Internet Communication Manager. Multiple SAP instances can run on a single host system. Each SAP instance has an instance ID, which is a two-digit number. We address this SAP instance on a system by specifying the SAP instance ID in a service name, following a naming convention by SAP. The service name starts with SAP GW GW stands for gateway, followed by the SAP instance ID. So SAP instance ID 01 is specified by a service name SAP DW01, like here. The service name is mapped to a TCP port number in etc services file on the local system, where the VSE recorder or the virtual service are launched. The second option is to address an SAP system by its SAP message server. An SAP implementation can comprise of multiple SAP systems. Each SAP system has a single message server which knows the SAP instances of the SAP system and is able to route messages to their destinations. Over here. Each SAP system has an SAP system ID, which is a 3-character string. L00 is a quite common SAP system ID. We address this SAP system by specifying the SAP system ID in a service name too, again following SAP's naming convention. The service name starts with SAP MS for message server, followed by the SAP system ID. So SAP system L00 is specified by a service name SAP MS L00. And again, the SAP service name maps to a TCP port number in the etc services file. We also need to specify the R3 group name that defines the set of application instances which is able to process our messages that we send to the system. Technically, messages are exchanged between SAP systems by RFC calls. RFC means remote function call and is the SAP standard for communication and information exchange with other systems. There are different types of remote function calls, such as asynchronous RFC, transactional RFCs, or queued RFC. We use transactional RFC in our demo. In order to enable Java-based applications to connect to SAP, SAP provides a Java API in its so-called Java Connector package or SAP JCO package. This package comprises of 2 jar files and a platform-specific library. The jar files cover the JCO communication and the IDoc processing. The library executes the native RFC interface to the SAP system. The data exchanged between SAP systems are called IDocs, intermediate documents. An IDoc consists of 3 sections over here. A control section that contains message information to identify and to route the message. A data section which contains the payload, and a status section down here that contains segments tracking the status of the IDoc on the local system. The control section has a single segment only. The data section can have multiple segments, even in a hierarchical order, like you can see here in that extended view. The status section can also have multiple sections. Old status records are not discarded, but new status records are added to the existing ones. So you can review the history of the IDoc status by the list of its status records. When an IDoc is sent from system A to system B, status information is not passed along, but stripped off and stored in system A. And new and existing status records are added to the IDoc when received in system B. This is worthwhile to know if you want to check the status of an IDoc that was sent from in system A or that was received in system B. When two SAP systems communicate, system A sends an IDoc to system B. In our demo environment, we have two SAP systems, CR2 and CS2. CR2 is the SAP client and CS2 is the SAP server. In CR2 system, CS2 can be addressed as CS2 client 100 over here. The control section of the IDoc contains the sender information so that B knows where to send the response to after the IDoc was received and processed. In our demo example, system CR2 sends an IDoc known as HRMD ABA04, which is a human resources document. CS2 responds by an IDoc known as black IDoc 01, which is, acknowledges that the IDoc was received on the server side and processed. When we record the traffic between two SAP systems, we play the man in the middle as usual. We configure the system CR2. Okay. We reconfigure system CR2 to send the IDoc request to the DevTest instead. In system CR2, DevTest is known here as DevT demo 1. When we receive the IDoc from the client, the specialty of the SAP communication unfolds. CR2 does not send us the entire IDoc, but a subset of the IDoc structure only, particularly the payload. In order to completely process the message, we need to retrieve the IDoc structure from a repository first. This repository is called the IDoc metadata repository. In order to get access to that repository, we connect back to the repository server and retrieve this information. This retrieval is done once per IDoc and once per session. Once we have the complete IDoc structure available in DevTest, we forward the information to the intended server, CS2 in this case, receive the server's response, down here, retrieve the complete IDoc from the for that IDoc as well from the metadata repository, which could be a different one, and forward the response to the client. The dotted lines show the communication between the DevTest server and the SAP systems to retrieve the IDoc metadata from the repository. As said, this is executed only once upon first reception of each IDoc. In replay mode, once we have the virtual service for SAP up and running, the SAP client CR2 again sends the IDoc request, this time to our virtual service. The virtual service behaves like the VSE recorder and retrieves the complete IDoc information from the metadata repository. It locates the correct response in the virtual service image and returns the response to the SAP client again. In order to send IDocs to DevTest, several configuration steps must be completed on the SAP system. This is usually done by the SAP system administrator. The DevTest server, meaning the system where the VSE or the VSE recorder are running, must be configured in SAP as a so-called logical system. The partner profile determines the outbound and inbound IDocs that the DevTest system understands and returns. The partner profile must also be specified and assigned to the logical system. It is information in the partner profile that the DevTest service subscribes to in order to listen for the DevTest service, in order to listen for the IDoc request from the SAP client. To confuse things, often the partner profile gets the same name as the logical system, but that's not required to do. Finally, we need an SAP user ID, which the virtual service uses to connect to the SAP system and to the IDoc metadata repository. This user ID must have the proper privileges to access the repository and to read the IDoc metadata. Sorry. We have also utilities available in SAP to test the connectivity to DevTest. However, those connectivity tests only work if we have a virtual service or the recorder running. In DevTest Workstation, we can create SAP JCO destination assets to test the outbound connection settings to SAP. Depending on whether you want to connect to an application server or to a message server, you get a different UI. To connect to an application server, you have to specify the host name and the SAP instance ID, those two parameters. This is also known as the SAP system number. Additionally, you have to provide the credentials to log into that system. The specialty of SAP is that the user ID is associated with a client ID, with a client number, which is actually a kind of a tenant identification. So your user ID is only valid within within this client. You can test the SAP connection settings by clicking on the execution, on the green arrow, on the execution button over there, which will then give you check whether you can set up a connection to SAP. Second, alternatively, you can specify the message server to connect to the SAP system. For this type of connection, you need to specify, again, the host name, the SAP system ID or R3 name, the R3 group name, to identify the set of application instances that is capable of processing our IDoc request. Again, you have to specify the user credentials to access the SAP system. And you use the green arrow icon to test the connection. Recording the communication between DevTest and SAP. In case of recording, we need to identify the configuration parameters that we have to set in the VSE recorder and the virtual SAP service in order to talk to both the SAP client at CR2 and this part and to the server on this side. So we need information about how to listen for incoming IDoc requests from CR2, how to connect to the IDoc repository on CR2, how to forward IDoc request to CS2, how to connect to the IDoc repository on CS2, and how to forward the IDoc responses to CR2. So we need to specify RFC destinations on CR2 and CS2 on both the sides to connect to DevTest. For this IDoc on this side and for the ZAC IDoc from CS2. And we need to specify the connection settings to connect from DevTest to the SAP to CR2, to to connect to the repositories and to return the response. Same on this side, we need to actively connect to the CS2 server to forward the request and to connect to the repository. DevTest uses SAP JCO to connect to SAP systems. JCO requires connection settings specified in properties files. So the virtual service image recorder asks for the location of those connection properties files in the wizard. In the VS, in the VSE recorder, we have to also specify the settings for the SAP client side on the upper part, and for the server SAP server side, which is the lower part. On the SAP client side, the first properties file specifies where we listen, how we listen to for the IDoc request. The second one, the second parameter, we have to specify a unique name for that connection. The third parameter, I'm having trouble with the presentation right now. Okay. The third parameter contains the JCO settings to send the responses back to the client. The next parameter specifies the SAP system ID of the IDoc repository where we can retrieve the information about the IDoc request. On the SAP server side, we specify, on the SAP server side, we specify the equivalent settings. The first parameter again specifies the property file that contains the JCO's connection settings to listen for the IDoc responses. The second parameter defines a connection name that's unique on the local system. The third parameter defines the properties file containing the JCO connection settings to forward the IDoc requests to. The fourth parameter identifies the IDoc repository for the IDoc response structure. And the XPath expressions are required to locate the correlation IDs in the IDoc requests and the IDoc responses to match up the response to a request. If you create the virtual service from RR pairs, we need to configure the SAP JCO IDoc listener step in the virtual service model. The settings have the same meanings as in the VSE recorder. However, we do not need to specify this SAP server side of the communication, of course. Again, on the client side, the same parameter settings apply. The first one is the settings for listening for the IDoc requests, the unique name, and the second one, the specification for returning the IDoc responses, the SAP system ID, where to get the to access the metadata repository, and the two XPath expressions to match up responses and requests. Okay. Now let's have a closer look at the contents of those connection properties files. First, let's look at the JCO connection parameter settings that are used to listen for incoming requests or responses. These are equivalent for both sides, for the client and for the server side. However, as you remember, we need two files for each of them, one file for each of them. The first one, the JCO server POC ID, is sorry, this screenshot is too small. It's very small. The first one, the JCO server POC ID, is the registered program name in the RFC destination definition in SAP. So that's the most important information you need there, and you can retrieve that information from within SAP from the RFC destination definition in SAP. JCO server GW host specifies the host where SAP is running on. JCO server GW service defines the service port of the application server where we need to connect to. JCO server connection count specifies the concurrent connections that can be established between the SAP system and DevTest. The setting should match its counterpart in SAP. So we do not necessarily have only one connection between SAP and DevTest, but multiple ones. And SAP can then forward multiple IDoc requests down to DevTest. We have done performance tests with up to 20 connections between SAP and DevTest. The RFC, hold on. Yeah. JCO server.unicode specifies whether Unicode is used in the communication between the SAP client and DevTest. And if we configure Unicode to be used here, it must match the RFC destination configuration in SAP. If it doesn't, we receive the IDocs, but we cannot process them. The trace level specifies the granularity of the traces. JCO trace files are stored in Lisa Home. They are not stored in Lisa Home, Lisa Temp, or not the Lisa Temp directory. So in the Lisa Home directory. The repository destination settings refers to an SAP system that hosts the IDoc repository. JCO uses an available connection configuration to access this SAP system. To forward IDoc requests and responses to the intended receivers, we need to actively connect to these SAP systems. As mentioned before, we can either do this by connecting to the SAP message server or the SAP application instance. As with SAP and JCO destination asset, the SAP settings, JCO settings are slightly different. They differ on the details of addressing the target system. For the message server connection, we need to specify first the type of the connection, which is always stream, meaning that it is a connection to an R3 system. The next three settings specify that the message server for an SAP system is running, for the SAP system CR2 is running on that host there. And we want to connect to this base application group. The following next four settings apply to supply the SAP login credentials to connect to the SAP system and the language that is used for the login. The trace level, again, is for the granularity of the trace, and we define this connection to be used to access the SAP system ID, to access the SAP system. To connect to an SAP application instance, the parameters are pretty much the same, except for specifying the host information. Again, the connection type is free again. For the application server instance, we need the host name in JCO client.as host for application server, and we need to specify the SAP instance ID in JCO client.system number. Again, SAP credentials are the same as for the message server, trace level, and using that connection settings for accessing the SAP, the IDoc metadata repository. For the correct definition of the virtual service recorder, we have to determine how requests and responses match. In our demo example, we match the user ID of the records. In the IDoc request, this leads to this XPath expression to locate this information. In the response IDoc, the XPath expression to the user ID information looks like this. Well, I've applied the XPath expressions to the virtual service image in Workstation. Eventually, we have to make sure that the SAP services are defined in our etc services file. So we have to, the etc services file, probably know that where is in Windows in the Windows subfolder, and we have to specify the message server services manually, and the application server services are created automatically if we install the SAP GUI component on the system. But keep in mind that the message server services must be added manually. In summary, here's a list of configuration settings that need to be fulfilled prior to starting the creation of a virtual SAP service. You need to bring the latest SAP JCO libraries and copy them to their respective locations. The SAP system administrator should have provided you with SAP user credentials, including the SAP client ID. This user ID must have the privilege to access the IDoc metadata repository to read the IDoc metadata. The SAP administrator should also have given you the connection settings of the SAP client system, where to listen for the SAP IDoc requests and where to send the IDoc responses to. If you need to record the communication between SAP client and SAP server, you need the same information, the same connection information for the SAP server. The SAP application engineer should have given you the information about the criteria that associates an IDoc request response to an IDoc request. This information should enable you to create the correct XPath expressions for both the IDoc requests and the response. You have to make sure to have the correct SAP service and port definitions in your etc services file on your workstation for the recorder and on the VSE for the virtual service. If you install the SAP, as I mentioned, that these definitions are installed automatically or created automatically if you install the SAP GUI. If you do not want to record the communication between SAP client and SAP server, you can create a virtual SAP service from IDoc RR pairs. The IDoc RR pairs must come in XML format, not in the standard SAP EDI format. Otherwise, DevTest is unable to create the virtual SAP service. The SAP application engineer should be able to export IDocs in XML format. This is supported by SAP. Okay, so much about the theory. Now let's go to the playground for the demo. Okay, quickly stop this one. We need to share monitor 2. Yeah. Can you see my desktop?
Yeah, we can see it. Looks good.
Perfect. Okay, so we are in the DevTest workstation, and the first thing we want to do is to have a quick look at the properties files that we use to connect to the SAP client and the SAP server. The CR2 files are used for the connection to the SAP client, and the CS2 files are used to connect to the SAP server. They are pretty much, I don't want to say identical, but equivalent. So to connect to the CR2 server client, we have specified the program ID, the host, and the gateways. And we have also specified the connection settings to access, to return the IDoc responses back to the SAP client. The first thing I recommend to do is when you have those connection information to use the JCO destination assets that you have that you can create in the workstation, and to check those settings up front. So the first thing I do is I want to check whether those settings can be used to connect to the SAP system, to the SAP client. I've applied the same ones here. Of course, that's usually what happens in the demo. Let me check whether it can still ping the machine. Okay. Let's stop and start the connect workstation again. Open. So yeah, so we successfully checked that we can establish a connection to the SAP system CR2. Now let's do the same with the CS2 system. Yeah, and this one works as well. So we are now able to actively connect to both this client and the server side. Now let's try and set up the recorder to record the traffic between the SAP client and the SAP server. We create a new virtual service image, and I've prepared the configuration with a settings file. Give it a new name, call it Demo 5, in accordance with my previous tests. Click Next. And here we got the predefined settings using the properties files for the listening part, for the active part on the client side, for the listening and active part on the server side. So we can now start the recorder and switch over to our SAP GUI to launch the transaction, to start the IDoc submission. Okay. At first, we have started the recorder and then mentioned that we can try and test the connection from SAP to DevTest, and that's what we are what we're going to do first. We apply transaction code SM59 and go to the RC destination that has been created for this demo. So here we got the configuration settings. Hold on a second. Yeah, here you find the program ID that I mentioned in my presentation, which has gotten the same name as the RC destination and as the logical system name. This is the information that DevTest subscribes to listen for the IDoc requests. So we can start the connection test in this window from here, and we failed, of course. Okay. Last time it helped to restart, to cancel this one and restart it again. Let's go back and try again. Doesn't look good. Okay. Maybe I have to give it some more time. No. Okay, let's try again and restart the application. Okay. I want to check now whether we got a connection of to the SAP system in the log file. Not ready yet. Okay. According to the log file, connections are running. Let's check from SAP. Yeah, it's working now. So you've seen the failed test, and now this test succeeds and gives you some information, some statistics on the transfer rates. So now we are ready to launch the application, to submit the IDocs. And we use an application called PFAL. And this is a human resources application. We provide an ID. And yeah, the important part is now that we want to transfer that IDoc to DevTest, and we know that DevTest has been associated with this logical system ID. Yeah, submit this IDoc, and has been sent. Now let's go back to the recorder to see whether the recorder has received already something. Yeah, so the recorder got this IDoc request. It accessed the metadata repository to retrieve the metadata information about this IDoc, and we sent the IDoc request to the server, got a response, and did the same on the server side, and returned the server response back to the client. Now we save this information. We don't need the XML DPH. We have gotten a response. Save this information. Yeah, and finish it. Let's close this one. So we can take a look at the VSI that has been recorded. Let's take a look at the response first, where we the wrong one. Here's the user ID information that we have recorded. Well, incidentally, that has been a record about me, about myself. And the request data, launch the extended view and format this part. We can navigate down here to see that information. Thinking another one should be in the 1, 2, 3, 4, 5, 6, 7 should be there. Yeah, there's the user ID. That the matching criteria. Okay, now let's deploy the virtual service. Don't want to start it. And go to the portal where we want to start the virtual service from here. What's that? Let's do a refresh here. I'm using the 10.0 build, which is not released yet, but will be soon. So this is not yet complete. Okay, has been executed, has been started now. Now let's go back to the application, to the SAP application, and let's redo that request. Has been processed. Let's wait to refresh to check whether the IDoc, has been submitted to the request and has been sent to the virtual service, and the virtual service has responded back to the client. We can check the response in SAP using transaction WE05. Let's query those transactions. So here we can see the list of recently sent IDoc requests. Down here is the latest one. This is the IDoc. This is the HRMD ABA IDoc request, and that's the response received from DevTest. So we can resend. We can take a look at. We can analyze the request, but we can also use the GUI to the SAP GUI to send the latest IDoc request multiple times. Again, let's query the send IDocs. Pick the latest one that we send and resend the IDoc again, not once, but let's say, let's submit it 5 times the same IDoc. Now let's take a look at our virtual service. And we see that 5 IDocs has been sent to the virtual service and have been responded to. That's about the demo. And I think we should conclude the session by 2 more slides. Share again, monitor 1, and let's launch the demo again. Can you see the demo, the slides again?
Yes.
Yes. Okay. So I want to conclude with 2 additional slides. Some best practices we found during some SE engagements about SAP virtualization. First is that you want to get the communication configuration information in advance so that you can prepare the DevTest resources before you attempt to create the virtual service. When you have access to the target SAP systems, you should validate the configuration data, either online on the system or together with the SAP administrator. If you do not want to record the communication, you should try to get the SAP IDoc RR pairs in advance. If you have an internal SAP test system at hand, you should be able to create the virtual service with the RR pairs in advance using connection settings of the in-house SAP test systems. You cannot test the created virtual service, but you can, by this approach, we can prove that the XML format of the RR pairs is correct. It also helps you to determine the required XPath expressions to correlate IDoc responses to requests. In the past, often two appointments were required to create a virtual SAP service. The first appointment was used to set up and test the communication between DevTest and SAP systems and to validate that the created virtual SAP service receives and processes the IDoc requests and responses correctly. In the second appointment, the use cases were tested, meaning new recordings were created, the virtual services were extended or customized. It also proved very useful to have support from SAP administrators and application engineers or developers while you are creating those virtual services. This is critical from my point of view to a timely success if you want to virtualize an SAP service. They will help you to fix issues or create workarounds if you run into issues with the SAP system or the application. Well, to the slide deck that you can download, I've added some of the transaction codes and some troubleshooting information for your convenience. I don't want to go through those slides now because we are running out of time. So I want to just proceed to the end of the presentation for the summary, what we did. So we showed the concept of virtualization of SAP services in DevTest. We discussed the SAP configuration properties in and for DevTest in detail. We provided a list of items to prepare and to bring if you want to virtualize SAP services, and offered some recommendations on how to approach such a request. Well, we haven't, the slide deck, as I said, contains a set of important transaction codes to validate the SAP configuration and to test the communication between SAP and DevTest. And we provided some hints on potential root causes and resolutions for some of the common problems that you may encounter when setting up DevTest to virtualize an SAP service. So we've got maybe a minute left or two to talk about questions.
Okay, we're now going to open up for questions. If you have any questions, feel free to put them in the Q&A box in the bottom right-hand corner of the screen. Or if you'd like to ask a verbal question, you can click #6 on your telephone keypad to unmute yourself. Just going to pause for just a second. And just another reminder that it's #6 on the telephone keypad to unmute yourself, or Q&A box in the bottom right-hand corner of the screen. Okay, if there are no questions, I think we'll wrap up for today. Thank you everyone so much for joining. There is a poll available, should pop up on the right-hand side of your screen. Please let us know what you thought about today's topic. We definitely like to get your feedback on that so we can pick out topics moving forward. We have another webcast coming up next week, and that is going to be service virtualization and TDM integration, test data manager. So if you're interested in that, you can head to the DevTest community and RSVP for that right now. Otherwise, if you have any questions that you think of later, you can go to the community, or you can always reach out to Ulrich or myself. We're happy to help in any way we can. Okay, yes. Anything else, Ulrich?
Yes, thank you very much for attending, and please forward any questions you may have to my attention. Thank you very much.
All right. Thank you, Ulrich, and thank you everyone for joining. Have a great day.
Have a great. Thank you.